Yes, ma'am.
No, no. Of course, నేను document కనపడు. Now we are going to start the lecture, girls. Good afternoon. And so far, 19 students joined the class. I'm going to start the lecture today. The lecture is on great circle and small circle. The moment I start sharing, you please let me know whether you are able to see the document. Can you see the document, girls?
Yes, ma'am.
Yes.
Yes,
Let me
ma'am.
start the
Yes, ma'am.
class. Yes. Let me start the class, girls. This topic is on great circle and small circle, girls. Already in the previous two classes, I discussed about what a great circle is and what a small circle is. Here is once again I'm explaining, girls. Here, see, if you have a sphere in red and a plane C here, if they intersect, then the section is a circle, okay, and this circle would be either a great circle or a small circle. But here if you see, the center of the sphere and the center of the circle is the same. Moreover, the center of the sphere is lying on the plane. That's why this circle is a great circle. Okay, when a sphere and a plane intersect, you will get a circle. That circle is either a great circle or a small circle. This is great circle because the center and radius of the sphere is same as this, are same as the center and radius of the circle, and moreover the center of the sphere is lying on the plane. Okay, now let us identify. This is how, if you have a picture, you can identify whether the circle is a great circle or a small circle. But when you are given a problem, like see, he gave you a circle. I told you, no, circle means intersection of a sphere and a plane. So he gave you a circle. I'll just correct here. This is a circle, girls. Here we have a sphere and here we have a plane. When a sphere intersects a plane, you get a circle. Now, he gave you here a circle and he's asking you to check whether it is a great circle or a small circle. Okay, so here in a picture means you can identify, but now how will you identify? What did I say? If it is a great circle, the center of the sphere must be on the plane. Okay, that is what I did here. See, first of all, you have a sphere now. Okay, sphere equation, you compare the sphere equation with the general equation of the sphere. Okay, so here x square terms, y square terms, z square terms, and here we have 2ux, means coefficient of x is 2u, and here coefficient of x is equal to -4. You compare the like terms. So what do we get? Here x coefficient is 2u. So 2u is equal to, here x coefficient is -4. And here y coefficient is 2v. Here y coefficient is 6. And here the z coefficient is 2w. Here the z coefficient is -8. Okay, so you compare the given sphere with the general equation of the sphere. Comparing means like terms, girls. So coefficients of x, coefficients of y, coefficients of z, I compared and I got 2u, 2v, 2w. 2u is here coefficient of x -4. 2v is coefficient of y 6. 2w is coefficient of z -8. So from which you get u -2, v 3, w -4. So center of the sphere is -u, comma, -v, comma, -w. So I put here the center as 2, -u means here 2, -v here is -3, -w here is 4. Now we are checking whether the center of the sphere lies on the plane given. Okay, so what is the equation of the plane? X plus y plus z -3 is equal to 0. I'm now checking whether the center satisfies the equation of the plane. So I took left hand side of the plane, which is x plus y plus z -3, and in this I substituted for x 2, y -3, z plus 4 and -3. When you substitute for these values of x, y, z, you got 0. Means what? Which is equal to right hand side of the plane. Okay, now what happened? The center of the sphere, given sphere, is lying on the plane because it is satisfying the equation of the plane. Okay, what did I say? If it is to be a great circle, the center of the sphere must be on the plane. Okay, but why am I doing still something else? See, first of all, you have a sphere and you have a plane, and you got the section of the plane section of the sphere as a circle. Okay, and this circle you are identifying whether it is a great circle or a small circle. Okay, so as the center of the sphere is lying on the plane, it is confirmed that the given circle s is equal to 0 is equal to pi is a great circle. You just now go through the remaining part of the question. What am I doing here is I'm finding out a sphere. I'm finding out a sphere through the circle s is equal to 0 is equal to pi. Okay, we are able to identify that the given circle is a great circle, girls. There ends the matter. But why am I doing the other part is I'm going to find out first a sphere which is passing through the given circle. What is the given circle? Here s is equal to 0 is equal to pi. This is the given circle. So I'm finding out a sphere which is passing through the given circle. And I'm going to say that sphere and the given sphere are the same. Okay, for that reason I'm going to do the problem again continuously. Continuation. Now see what I'm doing is I'm finding out a sphere, equation of a sphere passing through the circle s is equal to 0 is pi. Means I gave you a formula, no? Equation of the sphere passing through the circle s is equal to 0 is equal to pi is s plus lambda pi is equal to 0. Okay, this is your s, the sphere, and this is your plane pi. So s plus lambda pi is equal to 0. Okay, so this is now what we are going to do is we are finding out a sphere which passes through the given circle. Okay, so that we are calling it as s dash. S dash is the sphere passing through the given circle. S is equal to 0 is equal to pi. S is equal to 0 is equal to pi. So now what we have to do, we are going to find a sphere now. Sphere standard form is x square term, y square term, z square term, x term, y term, z term, and constant term. So what I did is from this I put all x square, y square, z square terms, and then I take x common here. So minus 4 plus lambda. And if I take y common, I get 6 plus lambda. When I take z common, I get minus 8 plus lambda. Okay, and constant term. Here we have plus 4, here you have minus 3 lambda. So this is the sphere, girls. What is this sphere? This sphere is passing through the given circle. Given circle means you are given a sphere and a plane. That sphere is S. This sphere is S dash. I'm finding out a sphere, a new sphere, which passes through the given circle. In the given circle, already you have a sphere, girls. Okay, that sphere and given plane, when they intersect, you get a circle. Now I'm finding out a sphere which is named by like S dash, okay, denoted by S dash. This is the sphere which is passing through the given circle, and given circle is intersection of a sphere and a plane. So now this is a sphere. Your idea is now to find out a sphere passing through the given circle. So now you have to find out lambda. To get the lambda value, see here what I'm doing is, here this I'm comparing with again the general equation of the sphere. So here x coefficient is 2u. Here x coefficient is minus 4 plus lambda. So 2u is equal to minus 4 plus lambda, from which you get u as minus 4 plus lambda by 2. Next, you compare y terms. See here, coefficient of y is 2v. Here, the coefficient of y is 6 plus lambda. So, 2v is equal to 6 plus lambda. So, v is equal to 6 plus lambda by 2. Now, you equate the coefficients of z. Here, the coefficient of z is 2w. Here, the coefficient of z is minus 8 plus lambda. So, when you equate them, you get w as minus 8 plus lambda by 2. So now you are ready to write the center of this sphere which is passing through the given circle. So center of the sphere S dash, let us denote it by C, which is minus U comma minus V comma minus W. So C is, this is U, no, minus of it is minus U, and this is V, minus of it is minus V. This is W, so we need here minus of W. So minus of this will be minus W. So we are able to find out the sphere's center, and this sphere is the sphere passing through the given circle. So now I'm checking whether this center also lies on the given plane. See here, what did I do in the first step? I checked whether the center of the given sphere lies on the plane. The same way, I found out now a no sphere which is passing through a circle, and I'm finding out whether this center of this sphere also lies on the given plane. So for that, I took left hand side. Okay, if at all C lies on the plane and the center of this sphere, this new sphere lies on the plane, it will satisfy the equation of the plane. No, so what did I do? In place of x, I substitute this x coordinate. In place of y, I put y coordinate. In place of z, I put z coordinate. There is plus in between, girls. So this is substituting the values of x, y, z in this plane and equate it to 0, because C lies on the plane. If at all C lies on the plane, it satisfies the equation of the plane. From which, if you simplify, and then you get lambda as 0. So once you get lambda value 0, you substitute this lambda value in the center of this sphere, girls, so that you get the center of the sphere as 2 comma minus 3 comma 4. See, this is a sphere which passes through given circle. Okay, and this center of this sphere is same as the center of the given sphere, girls. Okay, so what you can finally conclude from this? Actually, we are given a sphere and a plane, both are intersecting in a circle. Okay, so you are now identifying the equation of the sphere which passes through this circle. So the equation of the sphere S dash which passes through the circle is same as the equation of the given sphere, girls. Okay, means the center and this sphere and the sphere which is passing through the given circle, they are the same. Okay, so that you can conclude that as the centers of the given sphere and the sphere passing through the great circle are the same, the given circle is a great circle. See what we did at the end after confirming that the center of the sphere is lying on the plane, so it is a great circle. You are now making sure that the sphere passing through the circle is same as this sphere. Okay, so this is the great circle. So now we once you are given a circle, you will know whether it is a great circle or a small circle. How? By checking that the center of the given sphere lies on the plane. Okay, but to find out the equation of the sphere passing through the circle, and that itself is the given sphere, is the other part of the question. So this question is an important question, can be asked for short answer. So basically you must know what a great circle is to do this problem, girls. Now let us move on to the next one, that is small circle. See, small circle I explained to you already twice. See here in the revision classes online. Now see here we have a sphere and we have a plane. See, a sphere and plane, they are intersecting. So the plane section of the sphere is a circle. That circle is either a great circle or a small circle. If you see here in this picture, the center of the sphere is not lying on the plane. That is why it is not a great circle. It is a small circle. Also, another property of small circle is the center of the circle is different from the center of the sphere. Okay, and also the center of the circle is the foot of the perpendicular from the center of the sphere to the plane. Okay, so if it is a small circle, the center of the circle is different from the center of the sphere. Moreover, the center of the circle is the foot of the perpendicular from the center of the sphere to the plane. Okay, so this is the plane. From the center of the sphere, if you draw a perpendicular, it will meet the circle at some point, and that point is the center of the circle. Okay, so foot of the perpendicular, the center of the circle is the foot of the perpendicular drawn from the center of the sphere to the plane. Okay, so if you have a picture like this, you can make out whether this is a small circle or a great circle. But given an equation like this, see here again he gave you a sphere intersecting a plane. So a sphere and a plane, they are intersecting. So you have to identify whether this circle is A small circle or a great circle. So, like before, we'll proceed, girls, so that you will be able to understand the procedure. So, what were you given here? A sphere, we are denoting it by S, and a plane, we are denoting it by pi. Okay, here it is. So, now this sphere, which is denoted by S, is equal to 0. This plane, which is denoted by pi, is equal to 0, are intersecting, girls. So that is why I wrote it as S is equal to 0 is equal to pi. So this is the equation of the circle. When this sphere intersects this plane, you will get a circle. So you are given a circle. S is equal to 0 is equal to pi. So you have to now identify or say whether the circle is great circle or small circle. So what you have to do is, first you find out the center of the given sphere, girls, and you check whether that lies on the given plane. If the center of the given sphere lies on the plane, then it would be a great circle. So first of all, to find out the center of the given sphere, what did I say, girls? You compare the given equation of the sphere with the general equation of the sphere. What is the general equation of the sphere? X square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. When you compare these two equations, you will be able to get u value, v value, w value, of course d value. Now see here, coefficient of x is 2u. In this equation, coefficient of x is 12. So equating them, you get 2u is equal to 12. In this one, coefficient of y is 2v. Here coefficient of y is minus 12. When you equate, you will get 12. 2v is equal to minus 12. Now you equate the coefficients of z. Here it is 2w. The coefficient of z here is minus 16. 2w is minus 16. So that u is equal to 12 by 2, 6. V is equal to minus 12 by 2, minus 6. W is equal to minus 16 by 2, minus 8. So you are able to get now the center of the given sphere, girls, which is minus u comma minus v comma minus w, and that is minus u means here minus 6. Minus v means here v is equal to minus 6. Minus v means 6. Minus w means here w is minus 8. Minus w is 8. Please be very careful in writing the center, girls. You will be getting uvw, but we need minus u, minus v, minus w. So minus of these values only will be here. Okay. Now you are able to get the center of the given sphere, and now you are checking whether this center lies on the given plane. So for that, what you have to do, as I explained to you in the first problem, you take the left hand side of the given plane pi, girls, which is here 2x plus 2y plus z minus 17. So I took it now and I'm substituting the center here for x, y, z. So 2 into, in place of x, minus 6. 2 into, in place of y, put 6, and z is plus 8 and minus 17. So here minus 12 plus 12 is 0. 8 minus 17 is minus 9, which is different from 0, which is not equal to 0. Means the center of the sphere is not satisfying the equation of the plane. Okay. In the previous problem, after substituting the values, you got 0. Means you said that center is satisfying the plane, and therefore the center lies on the plane. Now the point center is not satisfying the equation of the plane because you didn't get here 0. Therefore, your conclusion is the center of the sphere, S is equal to 0, does not lie on the plane, girls. That's why it is a small circle. Okay, that is why it is a small circle. But now I'm finding out the equation of the sphere passing through this circle. Like this we did in first question also, but there, after finding out the equation of the sphere passing through the circle, that sphere and given sphere, they are having the same centers. So you are able to say that the circle is confirmed, that the circle is a great circle. Now you will be getting a different sphere, girls, because the sphere passing through the circle would be here. You understood, girls? So this is a sphere passing through, already it is a, this is a circle, this is a section of the plane section of the sphere. So you are now confirming this being a small circle could be like this, girls. Now you are confirming that the equation of the sphere passing through the circle will be having some other center. So what I'm going to do now here is I'm finding out the equation of the sphere through the circle, given circle. What is the given circle? There is a sphere, there is a plane, both are intersecting. So the equation of the sphere passing through the circle, S is equal to 0 is equal to pi, is this formula S plus lambda pi is equal to 0. Okay, here this is S girls, your sphere plus lambda, your pi. So S plus lambda pi is equal to 0. So this is a sphere now. You must put it in the standard form. General equation of the sphere is x square term, y square term, z square term, x term, y term, z term and constant. Okay. So here I put all x square, y square, z square terms, and here there is x term, here there is x term. If I take x common, here you will have 12, here you have 2 lambda. 12 plus 2 lambda, and from this and this term if you take y common you get minus 12 plus here there is 2 lambda, and from the z here minus 16 z, here you have some lambda z. If you take z common you will get minus 16 plus lambda, and the remaining thing is constant. Here 111 triple one and minus 17 lambda. Okay, this is the equation of the sphere with the three square terms, x term, y term, z term and constant. Okay, now I'm finding out the center of this sphere girls, and this is the sphere passing through the given circle. Okay, that sphere may be the given sphere, may not be the sphere girls. Okay, so we are now confirming it. So comparing this equation with this equation, you will have to find out UVW, from which you can write the center of the sphere. Now see here, coefficients of x I'm comparing. The coefficient of x here is 2u. The coefficient of x here is 12 plus 2 lambda. When you equate them, you get u as 12 plus 2 lambda by 2. Okay. Next, you equate the coefficients of y. The coefficient of y here is 2v. The coefficient of y here is minus 12 plus 2 lambda. When you equate them, you get 2v is equal to minus 12 plus 2 lambda, from which you get v value. Okay. Next, compare the coefficients of z. Here the z coefficient is 2w. Here the z coefficient is minus 16 plus lambda. When you compare them, 2w is equal to minus 16 plus lambda, from which you get w value. So you are now ready to write the center of the sphere S dash girls. Okay, given sphere we denote it by S is equal to 0. Now you are finding out a sphere which is passing through the circle. S is equal to 0 is equal to pi, and we denote it by S dash. So the center of this is new sphere is minus u comma minus v comma minus w. So minus of u. Here u is equal to 12 plus 2 lambda by 2. So minus, don't forget here to write minus sign. If you have here minus, minus, minus becomes plus. Okay. So it is only u girls, but we need here minus u. And it is only v here, we need minus v. And here you have w and we need minus w. Here only students usually make mistakes. Please see that you avoid such silly mistakes. So now you got the center of the sphere which is passing through the given circle. Now I have to check, like before how I checked the center of the given sphere, how whether it is lying on the plane or not. The same way I have to check whether, I mean check means we will take it as a point on the plane from which you get the lambda value, and from which you get the center of the sphere. And if the center of this sphere passing through the circle is same as the center of the sphere, given sphere, then you can confirm that the circle is a great circle. Now here the center of the sphere passing through the given circle is got. Now you got that. So what I'm doing is, if this center, if at all this lies on the plane, if at all this lies on the plane, it should satisfy the equation of the plane. Okay, so what did I do? For x I substituted this x component, for y I substituted y coordinate, for z I substitute z coordinate. So 2 into x plus 2 into y plus 1 into z. Here it should be plus, of course, plus. Here we have again minus, no? So finally it becomes minus only. So plus 1 into z Z means here we have minus, so minus minus 17 is equal to 0. So what did I do? I didn't cancel here 2 girls because there is an advantage. No, after cancelling you will get 6 plus lambda, of course, but there is an advantage here. That's why I did not cancel here 2. Okay, I took it as a fraction only. Now here these two will be cancelled. These two will be cancelled. So when I simplify, you get lambda value as minus 2. Okay, so lambda is minus 2 now. So substitute this lambda value in the center, you get the center of the sphere. Now this center of the sphere passing through the circle S is equal to 0 is equal to pi. It is minus 4, 8, 9. Whereas the center of the given sphere is here minus 6, 6, 8. They are not equal. That's why you can say that this circle is a small circle. Okay, so what we did here is first we checked whether the center of the given sphere satisfies the equation of the plane. There actually ends the matter, like whether you can say whether it is a great circle, small circle, but you are finding out whether the sphere passing through the circle is same as the sphere. Okay, so for that reason you are doing again, you are finding out the equation of the sphere passing through the given circle, and you are comparing the centers of these two spheres. Okay, so remember, first you think first thing is you first substitute the center of the sphere in the plane. If it is satisfied, great circle. If it is not satisfied, small circle. After that you have to find out a sphere passing through this circle. It could be like this also, no, like this. It could be like this. So you have to find out a sphere which passes through this circle and see whether that sphere center and this sphere center are equal. Okay, only these two steps you have to do for this type of problems. Okay. Any doubt, girls? Do you have any doubts, girls?
No, ma'am.
Okay. I will stop with this today, girls. You are going to do now two more problems. One is on great circle, one is on small circle. And my wish is you do at least 2 to 3 problems of this variety from examples and exercises, but submit only one problem of each type in the assignment.